Okay, so our first topic tonight is stream flow measurement. So stream flow, it represents the runoff phase of the hydrologic cycle. It is the most important basic data for hydrologic studies. So pag sinabi natin stream flow, so if naalala nyo, meron tayong concept ng outlet, di ba? Kung saan natin mini-measure yung ating flow. So yung outlet na yon, doon natin, meron tayo doong makukompute no, na area using sa field. Usually ang ginagamit natin is surveying, profile leveling, para malaman natin yung cross section, and then yung velocity usually that is measured using float method. So meron kang area, then multiply mo lang siya sa velocity, so meron ka ng Q. Yung Q, yun yung tinatawag nating stream flow. So it was seen in the previous chapters that precipitation, evaporation, and evapotranspiration are all difficult to measure exactly, and adopted methods have severe limitations. So yan yung mga discussion natin ng last time, no, na usually dahil sa complexity ng phenomenon, yung evaporation, evapotranspiration are difficult to measure exactly. No? Ibig sabihin yung very accurate. Even precipitation. That's why meron tayong kina-consider na error. However, yung measurement ng stream flow is fairly accurate siya, no, using mga methods natin. So it is the only part of the hydrologic cycle that can be measured accurately. So a stream can be defined as a flow channel into which the surface runoff from a specified basin drains. Generally, there is considerable exchange of water between a stream and the underground water. So pag sinabi mong stream, ang ibig sabihin lang yan is yung river channel, no, usually. So lahat ng mga maliliit na streams galing sa basin, so it all flows down, doon sila nagko-collapse, no, sa river channel. Tawag natin dyan, stream. So itong sinasabi niya na there is considerable exchange of water between a stream and the underground water. So ibig sabihin yan is yung base flow. No? So yung base flow, kapag walang ulan, so yan yung constant na flow ng tubig sa stream natin. So stream flow is measured in units of discharge occurring at a specified time, and it constitutes historical data. The measurement of discharge in a stream forms an important branch of hydrometry, the science and practice of water measurement. So as I've said earlier, discharge, no, yung units natin, that would be cubic meter per second. Usually kapag software, dalawa yan, no, it's either English or English saka SI. So sa English, we usually use cubic feet per second. SI is cubic meter per second. So there are many measurement techniques. So yung turo natin today is yung kaya lang natin isolve using mga numerical methods, no? So dalawa, no, direct determination and of course yung indirect determination. So yan yung dalawang categories. For direct determination, we have here area velocity method, dilution techniques, electromagnetic method, ultrasonic methods. Ang pinaka madaling gawin dyan is of course yung area velocity method. Direct determination, ibig sabihin, no, we use yung mga sophisticated na instruments in order to directly compute yung ating discharge. Indirect determination, what we usually use is yung mga weirs, no? Plumes and gated structures. So bale, di ba, those are flow measuring devices then that we've learned from hydraulics. So para ma-compute yung ating discharge. So the measurement is very important in many aspects because discharge is usually yung pinaka data na inaalam talaga sa research, no, when it comes to rainfall runoff modeling. So merong mechanical device that directly measures velocity, and then tawag natin dyan, no, yung current meter. I think I was able to discuss that sa concept ng runoff. Uh, so current meter nang ginagamit for velocity, and then multiply lang natin yan sa area to get discharge. Skip this one. Okay, and then yun yung sa current meters, and then for using floats, so ito is surprisingly, no, this is more used in sa research. Even sa experience ko as master, so yun yung usually na ina-adapt. Medyo hindi kasi available, no, yung mga current meters. So it's good to know, no, na merong mga current meters that directly measures the velocity. But ang reality is usually sa field, we use yung tinatawag float method. So a floating object on the surface of a stream in time can yield the surface velocity by the relation Vs equals S over T. So, bale, ang usual, ang standard na ginagamit natin is yung orange na fruit because hindi siya ganun sa submerge, hindi din siya ganun ka na nasa surface lang siya umaangat. So, by allowing a float, no, to flow from point A to point B, you'll measure the distance and then i-time mo lang siya. You already have now the velocity. So, this is considered primitive because hindi nga tayo gumagamit, no, ng sophisticated devices. But it is applicable for small stream that flood, or with a small stream with rapidly changing water surface, or mga exploratory survey. Okay. So now let's consider, no, yung mga numerical computations. Kikita nyo ba yung I think can you see the new slide? Okay, so let's have some sample problems. So here we have velocity using current meters. So the current meter observations from a gauging station are listed in the table below. So ito is naglagay sila, no, ng different current meters. So meron tayong current meter at the depth of 0. And then meron din sa 0.5, 1, 1.5, palalim ng palalim, no? And then ito yung nakuha na mga revolution, no, ng ating current meter. So it is measured, N here stands the number of revolution. So N over S, no, number of revolutions per second. So it was found out that at depth of 0.5, so 40 revolutions, no, per second, and then habang palalim ng palalim, no, pabilis ng pabilis yung ating stream flow. Then merong binigay na calibration constants doon sa current meters. A is 0.65 and B is 0.03. Whereas to compute the flow velocity at the given depth. So yung mga calibration constants, these are values, no, that is used to adjust the number of revolutions or yung pag-compute ng stream flow. So yung formula for velocity in terms of the constants would be V is equal to A plus V times N. So gagawin mo lang is direct substitution, no? So substitute mo yung A, and then yung B natin substitute din, and then N is ito, no, yung number of revolutions. So for instance, A is 0.65, B is 0.03. Ito na yung magiging governing equation mo sa pag-compute ng velocity per observation. So if you're going to substitute, no, let's say the first sa 0 na depth, so that would be 0 dito. So velocity would be 0.65. And then sa depth na 0.5, palitan mo lang tong n ng 40, no? And then you'll get a value of 1.85, no? So you may try that in your calculator, but that's basically it, no? Substitute mo lang yung number of revolutions dito sa n, and then you'll automatically get the velocities. Any question on our first example? Type none if nag-gets niyo yun. Okay. So madali lang naman, no? Substitute lang yung A at saka B and then yung number of revolutions. So meron ka ng values. So let's say tanungin ka what is the velocity at the depth 2. No? So tingnan mo lang to, 80, substitute ko dito. So the answer would be 3.05 meters per second. No? So ganyan lang yung pag-identify. Next, this time we're given the average velocity. Yung first is yung paggamit ng current meters. This time we will use the average velocity and discharge. So we have here the problem. The measured velocities on the center line of our rectangular channel, given na yung width daw ay 5 meters and then may lalim na 2 meters. Ang minessure na velocity is at a depth of 0.4 and 1.6 meter below the water surface. So it is found to be 1 meter and 0.5 meter. 1 and 0.5 meter per second respectively. So we're asked to find out the discharge of the channel. So ang method na to, ito yung tinatawag nating two-point method. So sa two-point method, what we do is we identify 2 points below the water surface and then find the average velocity of those 2 points. For instance, this is the cross-section of our outlet. And then ito yung width niya, that's 5 meters. And then itong buong depth niya is 2 meters. Okay. Ang first point na tiningnan natin is itong 0.4 meter na depth, no? So at this point, no, meron tayong i-measure na velocity. So most likely we will use current meter. And then another depth would be 0.6 meter. So paki-disregard to, no? This is just clerical error. Ayan. Okay, so to find out the value of the average velocity, the discharge, no, you will need area and velocity. So first, computing for velocity. So that will have to be just the velocity at that would be 0.6. Ito, 0.6 to. And then this would be 0.4. So binigyan naman tayo. At 0.4, it is 1 meter per second. Kabaliktad lang to. So that is 1 meter per second, and then sa 0.6, that is 0.5 meter per second. So you will now get the average velocity. So 1 plus 0.5 divided by 2, that would be 0.75 meter per second. So it's not the end yet, no? Multiply mo siya sa area. Q is equal to area times velocity. So yung area is area lang nitong cross-section natin. So since the cross-section is a rectangular channel, so multiply mo lang itong width na 5 meters times yung depth natin na 2 meters. So that would be 2 times 5. No? And then yung velocity natin average, which is 0.75. So what would be the value of Q? So you use your calculator to solve for Q. Nag-type sa chat box yung sagot. Okay, that would be 7.5 meter per second. So yun lang yung Q. No? So you might ask, Sir, bakit kailangan ng average? So alam natin no, from fluid mechanics na yung velocity profile ng ating liquids is not uniform no per depth. So yung nasa taas medyo mabilis yung flow or velocity, and then yung nasa ilalim medyo mahina. So para ma-compute yung average velocity sa stream, so ang ginagawa is ayan, 2-point average or 2-point method. So any question on this one? Okay, next is the area velocity approach. So we're given the data corresponding to a gauging station for a stream. So binigyan tayo ng distance from the left bank and the corresponding depth of the channel and the corresponding average velocity. So ang pinapahanap ngayon is ano yung magiging discharge sa stream. Okay? So ito medyo mas marami ang data points. So ibig sabihin nito medyo accurate din yung magiging sagot natin on a discharge. Okay, so bale ganito yung concept niya. So meron tayo ditong W1. Ito yung distance or ito yung width 1, no? Ito yung distance from the left. And then width 2, yan yung width or distance no, ng dalawang points. Width 3 and so on. Okay, so first gawa tayo ng table. Column 1 natin, distance from the left water edge. So of course, meron tayong 0. So it means nandito siya. And then next will be 1 meter. And then 3 meters. 5, and so on, hanggang 14. No? So, ibig sabihin 14 meters, no, yung width ng ating channel. So, para ma-compute mo yung W1, W2, W3, so of course, kailangan mong i-minus yan, no? So, gagawin mo para malaman mo yung width ng first, itong W1, so of course, yung distance na to, which is 1 minus 0. So, that would be 1. And then, continuous na yun, no? 3 minus 1, 2, 5 minus 3, 2, 7 minus 5, 2, 9 minus 7, 2, and so on. 11 minus 9. Okay. So, okay lang ba yan? Did you get it? Next is yung depth natin. So, this is given in the previous slide. So, lapag mo lang siya dyan. And then, to find for the average width, so meron tayong formula, no? So, to find the average width, ang gagawin lang natin is, kung titingnan mo, sa figure, ito yung W1. Okay? So, hanapin mo yung W1. So, sa data natin, kung ano yung first value ng width, yan yung W1. In this case, that would be 1. Followed by W2. So, yung W2 natin would be this one. So, the value is 2. So, substitute lang natin para makuha natin yung average width na 2. Ito yung formula na gagamitin natin. No? So, W1, palitan mo lang to ng 1. W2, palitan mo lang siya ng 2. And then, itong W1, palitan mo siya ng 1. If you substitute that to this equation, you'll get the value of 2. Now, since same lang naman tong values ng magkakasunod, so obviously, lahat ng yan ay 2. No? Then, ito, it's going to be 0. So, ganyan lang yung computation ng average width. No? So, gagamit lang tayo itong formula na to. Okay, followed by the area of the segment. So, pag sinabi mong area of the segment, ito yun. No? So, for instance, considering ito, area niyan. Yan yung segment na sinasabi. So, ito lang yung formula, WI, average, WI. So, ibig sabihin itong column na to, i-multiply mo siya sa YI, which is this one. So, yan na yun. No? So, ibig sabihin, 0 times 0, that is, of course, 0. 1 times 2 equals 2, and then 1.5 times 2 equals 3. 2.8 times 2 equals 5.6, and so on. Pababa dito. Okay, so this one is just, this is column 3, column 4. So, ano lang to, no? Column 3, multiply mo siya sa column 4. Next is yung average velocity. So, yung average velocity, this was given, or this is given in the previous slide. Check natin. Ayan, so given naman siya, ayan, average velocity. So, lalagay nyo lang to doon sa table corresponding sa values ng distance natin. Ayan, so lahat ng to, kinopya lang doon sa given. And then, to compute the discharge per segment, no, so yung area I, which is this one, multiply mo siya sa velocity. So, big sabihin, ano to, column 1, 2, 3, 4, 5. So, pag-compute ng discharge is just column 5 times velocity, no, column 6. Ito yung 5, ito yung 6. So, multiply mo lang yan dalawa. So, 2 times 0.3, that is equal to 0.6. 3 times 0.45, that is equal to 1.35, and so on. Okay, and then what you need to do to compute for the estimated discharge, sum up mo lang lahat ng compute mo, no, sa individual na QI. Okay? So, add mo lang to lahat. You'll get the value which is 13.75. That is now the answer. Okay po. Okay, you can take a screenshot and then let me know if you have questions. Otherwise, type none on the public chat. Okay, so okay na tayo, no? Tungkol sa stream flow. So you can delve more on the sample problems doon sa given na textbook as well as yung reference book natin sa Subramania. Okay, next topic natin are ang concept ng unit hydrograph. Or hydrographs. So, ano ba yung hydrograph? So, related actually siya sa stream flow. Hydrograph is simply a graphical representation ng watershed response, runoff response to a certain rainfall uh, in a specific duration. So, bali, graph siya ng time versus Q, as you can see here in ito, Q, yung nasa vertical, and then time, yung nasa horizontal. Okay, so naturally, sa ulan, di ba, we always start with discharge that is small. And then, such time, no, natataas siya, natataas. And then, kuha natin yung peak, no, na runoff. And then, bababa ulit. Okay, so ganyan yung normal graphing ng runoff. Okay, so pag sinabi mong unit hydrograph, ayan. So, response siya ng rainfall based doon sa tinatawag nating unit rainfall, no? Pag sinabi mong unit rainfall, so most likely that would be 1 millimeter ng depth. So why is it important? It helps estimate the timing and the magnitude of peak flows and the shape of the resulting hydrograph. So, bale, ang mangyayari dyan, if meron ka ng unit hydrograph, i-multiply mo na lang siya based sa magiging marirecord no, na depth ng isang rain gauge. So, let's say, umulan ng 10 mm, tapos alam mo na kung ano yung response ng ating stream based doon sa isang mm lang. So, i-multiply mo lang yung 10, no? Kung ano man lang hydrograph sa 1 mm, i-multiply mo siya ng 10, then you'll get the hydrograph on that particular rainfall. No? So they are derived from observed or synthetic rainfall data and represent the hydrological characteristics of watershed. So this is very applicable, especially if you're doing research no, in water. So they are used to predict runoff volume. So pag sinabi mong runoff volume in terms yan ng cubic meters. Peak flow rates, that is in terms of cubic meter per second. So pag sinabi mong peak, ano ba yung pinakamataas na value ng discharge no na nako-compute doon sa ating rainfall during a rainfall event. Okay, so they're essential for designing and managing watershed-related infrastructure. So, for instance, no, gusto natin na malaman ano yung pinaka mataas na discharge na pwedeng mangyari doon sa isang stream. So kapag meron ka ng unit hydrograph, then let's say mapipredict natin based on historical rainfall, meron tayong certain no, na most likely mangyayari, yun na yung pinaka-extreme. So let's say 500 mm na ulan, yan na yung let's say 100 year no na probability occurrence. So yung 500 mm na yon, i-multiply mo lang yung unit hydrograph times 500, malalaman mo na ano yung magiging Q. So with that, pwede kang maka-design ng mga water-related infrastructure kasi alam mo na yung magiging value ng Q. Okay, so for instance, no, binigyan na tayo dito ng ordinates ng unit hydrograph. So, ang ibig sabihin nito, sa 1 mm na hydrograph, ito yung magiging ordinates or magiging values ng discharge. So, at time 0, 0 yung value ng discharge. At 3 hours, it's 25 cubic meter per second and so on. So, nag-peak siya dito sa after 18 hours. So, yung magiging graph niya, no, would be ganito, no, Q and then time. And then, lagay mo dito 3, 6, 9, 12, and so on. And then, yung Q values natin, dapat equal din yung interval. So, it starts with 0, and then umakyat, and then bumaba. No? So, let's say, ito yung peak natin, assuming na yun yung 185. No? Pinakamataas na value. And then, bumaba ulit dito. Okay, so ano bang ibig sabihin itong calculate the ordinates of the DRH? So, pag sinabi mong DRH, it means duration recurrence interval hydrograph. Okay, and then ano ba yung DRH? So they are commonly used in hydrological analysis. No? So para mas simple, yung DRH, ito yung hydrograph ng isang ulan on a given rainfall data or let's say rainfall excess. So sabi dito, there is a rainfall excess of 3.5 centimeters occurring in 6 hours. So pag sinabi nating rainfall excess, yan yung amount of water no na naging runoff. So after all the obstructions, so yan yung lalim ng runoff ng 3.5 centimeters. Okay, so given na yung ating time at coordinate, so the solution is we just have to create a table, no? Pinopia lang natin to from the problem. Ayan yung peak natin, nasa 185. The start is 0, the end it's 0. Okay, so since this is the unit hydrograph, multiply mo lang siya sa excess, no? Rainfall excess na depth, that is 3.5. So, multiply by 3.5, then you'll get now the value of the DRH. So, multiply mo siya by 3.5. So, bale, itong values na to, these are yung unit no na sinasabi niya is ang 1 unit is 1 centimeter of rainfall excess. So ito yung na-compute niyang unit hydrograph per centimeter. So since the binigay is 3.5 cm, multiply mo lang siya by 3.5. Okay, so let's say 25 by 3.5. So of course that is 87.5. So you just do it pababa, multiply mo isa-isa. Now you have the ordinate of the hydrograph. Okay, nakuha po ba natin yon? Okay, so ito yung graph ng ating discharge. So sa 6-hour unit hydrograph, no, bale ito yung reference hydrograph natin, no. Ayan, pinat lang yung original given. Pagkatapos mong multiply ng 3.5 cm, so ganito na siya. Ganito na yung plot natin. Okay? Next problem. So we're given the ordinates of a 6-hour unit hydrograph of a catchment that is given. So unit hydrograph ulit, no? Yung given. Meron lang tayong additional na given. So mayroong binigay na accumulated rainfall after certain hours. And then binigyan din tayo ng storm loss rate for the catchment. So yung P index na tinatawag, which is 0.25 centimeters per hour. The base flow can be assumed to be 15 cubic meter per second. So pag sinabi mong base flow, ito yung mga tubig na galing sa groundwater, no, nagta-travel sa may um, saturated area ng ating soil. And then yung base flow daw, it increases by 2 cubic meter per second for every 12 hours. So may given a loss, may given a base flow, may given na accumulated rainfall, and then may given din tayo na unit hydrograph, no, or yung derived na catchment response doon sa ating mga ulan. Okay. So first is gawa muna tayo ng table, no? And then identify natin yung rainfall depth for the first 6 hours, and then the second 6 hours, and then the third 6 hours. So una is rainfall depth. So for the first 6 hours, given, no, na yung rainfall natin is 3.5. And then for the second 6 hours, at the 12-hour mark, naging 11. So ibig sabihin, ano yung rainfall depth na dagdag? So minus mo lang, no? 11 minus 3.5. So the answer is 7.5, no? So ibig sabihin, 7.5 cm yung nadagdag na rainfall depth after 12 hours. Guess po natin yan. Next, for the third 6 hours, so that is 18. So that would be 16.5 minus yung sum ng dalawa, no? That would be 11 after the 12-hour mark. So 6.5 minus 11, that is 5.5. So meron na tayong rainfall depth for the first 6 hours, for the second 6 hours, and the third 6 hours. Next is identify natin yung loss for every 6 hours. So sinabi dito that the loss rate is estimated as 0.25 centimeters per hour. No? So ibig sabihin for the first 6 hours, ano yung loss? So, multiply mo lang, di ba? 0.25 times 6. So for every 6 hours, meron tayong loss na 1.5. No? Saan galing yan? 0.25. And then since yung interval natin is every 6 hours, that is equal to 1.5 cm na nawawalang depth every 6 hours. Tama? Kaya tag 1.5 yan. Okay, gets po ba? Next is for the effective rainfall, i-minus mo lang ang depth at saka yung loss. So, pag sinabi mo effective rainfall, yan yung rainfall available for runoff. Minus mo lang yung ulan tapos yung loss. So, 3.5 minus 1.5, that is 2. 7.5 minus 1.5, that is equal to 6. 5.5 minus 1.5, that is equal to 4. So again, sinabtract lang natin itong dalawa. First two rows. So that's the first step. Okay, so any questions so far? Doon sa table na yan muna. Okay, so I'm assuming no na wala. So ilista lang natin yung mga values na effective rainfall. So we have 2, 6, and 4. Tandaan na natin yan. Ito na yun, no? 2, 6, and 4. So now, ilista natin yung values ng unit hydrograph no, in a tabular form. So ito, sinulat na natin yan. Kinopya lang po no, yung values doon sa given. So for instance, tingnan natin yung previous slide. Ito for instance, 3 hours. Yung ordinate ay 25. 6 is 50. So 25, 50, tandaan natin. Okay, so yan lang yan, no? 25, 50. And then yung mga values dito, 21, 27, yung mga nakasilid sa parenthesis, no? Kinuha lang yan using interpolation. So, now meron ka ng ordinates. So, we're now ready to compute for the DRH or yung hydrograph due to this 2 centimeter na effective rainfall. Ito yung naging runoff, ha? So, yung runoff po, yung nagko-contribute for hydrograph. Kaya, itong 2.0, yung i-multiply natin doon sa ordinate. No? Hindi yung rainfall, hindi yung loss, kundi yung runoff. So, 2.0, multiply lang natin dito sa 25. No? Or sa values ng ordinates ng unit hydrograph. So, yung 25 times 2, naging 50, and so on. No? Times 2. So, yan na yung rules pababa. So, you now have the hydrograph after a 2 centimeter value of effective rainfall for the first 6 hours. Okay? Next is the hydrograph due to 2 centimeter effective rainfall advanced by 6 hours. So, if advanced by 6 hours, ibig sabihin, no, wala muna tayong i-multiply na value ng effective rainfall for the first 6 hours. No? Pagdating natin sa 9th mark, so saka tayo mag-multiply ng 6. No? Ito yun, no? So, we will multiply yung ating given na ordinate by 6 kasi yan yung effective rainfall after 6 hours. So, 25 times 6, that would be 150 and so on. So, 50 times 6, that would be 300. 85 times 6, 710. 125 times 6, 750. And so on. So, again, sir, bakit walang value ng DRH sa first 6 hours? Again, because ang kinonsider lang natin is yung effect no ng runoff ng second 6 hours. So, bale, hindi natin consider yung sa first 6 hours. Okay, so next is the value of the hydrograph after the 12 hours. Oh. So, bale, nasa ano na tayo? Third 6 hours mark na tayo. So, multiply lang natin by 4.0 yung values ng unit hydrograph. So, again, we will skip the first 12 hours, and then saka tayo mag-multiply ng 4 after the first 12 hours. So, again, 25 lang yan times 4. Ayan. So, 25 times 4, that is 100. And then, 50 times 4, 200. 85 times 4, 340, and so on. So, next is, para malaman natin yung combined effect no, ng values of effective rainfall for each for the first 6 hours, second 6 hours, the third 6 hours. So, ipa-plus lang natin yung DRH for um, the first 6 hours, second 6 hours, and the third 6 hours. So, lahat ng to, pa-plus lang natin. So, 0, second row is 50 lang, third row is 100 lang, fourth row is 170 plus 150, that's 320, and so on. And then, considering base flow, so sinabi naman sa problem no, na yung base flow natin is sinabi na at the beginning, it is 15 cubic meter per second, and then every 12 hours, nag-i-increase ng 2. No? So, as you can see, so ito 15 to. So, for the first 9 hours, 15 muna. And then, pagdating ng 12 hour, nadagdagan ng 17. So, for the next, until 21, naka-17 yan. Pagdating ng another 12 hours, pang 24, dadagdagan ulit ng 2. And then, another 12 hours, sa 36, magiging 21. And then, another 12 hours, papuntang 48 mark. Dadagdagan ulit ng 2 hours. And then after 48, that's plus 12. So that is 60. So plus 2 ulit. So para malaman natin yung flood hydrograph, ipa-plus natin yung final DRH sa base flow. So ito na yung value ng discharge per after considering base flow and yung ating effective rainfall. So bale, ito na yung sagot natin. Okay. So again, what we did is first we considered effective rainfall for the first 6 hours. Okay. So for the first 6 hours, ayan, so lahat ng yan, minultiply natin ng 2. For the second 6 hours, so for the first 6 hours, hindi natin consider, so that's 0. And then after the 6th hour, no, saka tayo nag-multiply ng 6 effective rainfall. And then for the third 6 hours, so bale, that would be for the first 12 hours, 0, and then the rest, meron tayong value. And then, idagdag mo lang yung base flow kasi kasama yan sa computation ng hydrograph. No? The base flow plus the final DRH will get already the ordinates of the flood hydrograph. So, pag sinabi mong ordinates, those are all the values. Pero pag may tinanong na specific hour, let's say what is the hydrograph after 24 hours, so titingnan mo lang to. No? Yung table mo, so 24, and then hanapin mo lang kung ano yung total cubic meter per second after 24 hours. So that would be 1,949 cubic meter per second. Okay. So any question about hydrograph? You may type none if it's understandable. Okay, and then last topic for hydrology is groundwater and well hydraulics. So tulis ko muna yung groundwater concept. Okay, so for groundwater, so we'll identify and give importance to groundwater, differentiate the different properties and characteristics of an aquifer, discuss the different groundwater principles, and then discuss din natin yung difference ng hydraulics, pumping test, and aquifer parameter estimation. Okay, so pag sinabi natin groundwater, another term that we use to describe a groundwater is subsurface water. So basically, it's any water found beneath the Earth's surface, generally in oil or rock layers. So alam natin, no, yung mga soil natin, meron diyang mga voids. So yung mga ulan na nanggaling sa clouds, of course, will infiltrate doon sa ating soil. Then merong mga path, no, mga na tinitake yung ulan, yung mga voids natin sa ilalim. So tinatawag nating pores. So doon sila nagka-travel and then nagkaroon ng percolation until uh, ma-store sila, no, on the certain locations na tawag natin aquifer beneath the surface. So we're going to look at this one. Meron tayong tinatawag na zone of aeration and zone of saturation. So yung zone of aeration, these are voids that are still occupied by air. So yung soil water zone, intermediate, and yung capillary fringe. So soil water zones is where infiltration happens. Percolation happens in the intermediate and the capillary fringe. Pero yung pinaka-water table ng aquifer, bale yung, di ba, via gravity, so naiipon lahat ng tubig, no, sa layer na to. And if may bedrock, of course, impermeable ang bedrock, so talagang may ipon, no, yung tubig natin dyan. So ito yung saturated zone na tinatawag. This is the area that na tinatarget, no, ng mga humuhukay ng wells. So you need to get to the zone of saturation for you to dig a well. Okay, so as I've mentioned earlier, zone of aeration is where the pores are only partially saturated with water. Hindi siya purely air. What I said is meron siyang um, portion that is saturated by air. So, yan yung zone of aeration. So, ano yung tatlong subzone sa aeration? No? So, first is yung soil-water zone. So, this is where it lies close to the ground surface, as you can see, in the major root band of the vegetation. So, soil-water zone, dyan nasa-store no, yung water that is usable by the plants. Next is the intermediate zone. So, it lies between the soil, water, and the capillary fringe. So, pag sinabi mo capillary fringe, it extends from the water table upwards to the limit of the capillary rise. So, nangyayari ang capillary rise if we have voids that are less than 10 millimeters. No, if naalala nyo sa fluid mechanics, nagkakaroon ng capillary rise usually if the diameter is less than 10 mm. So, aakyat yan due to capillary action. And then zone of saturation, so lahat ng voids is filled with fluid. So those are called aquifers, no? Yung zones kung saan puno ng fluid. So meron din tayong tinatawag na mga saturated formations. Saturated formations, this lies in the which zone? Zone of saturation. So una is yung tinatawag nating aquifer. So these aquifers is a saturated formation of earth material which not only stores water but yields it insufficient quantity. No? So ibig sabihin there is a good amount of water that can be extracted in this particular zone. So as you can see here, this figure, meron tayong tinatawag na unconfined at saka confined aquifer. So pag sinabi mong unconfined aquifer, so at least one side of it no is covered by a permeable soil. So for instance, ito, so meron tubig na permeable and then meron isang layer naman na semi-permeable. Sinabi kong semi kasi partially water can still go through clay. But then in a yung hydraulic conductivity in clay is very small. No? It does not sufficiently allow water to pass through. Kaya nga yung filtration capacity niya is very small. Although there's a very small amount that goes inside. Another aquifer, so sinasabi natin confined siya if it is bounded by a bedrock where that is impermeable and meron tayong portion of clay na hindi that is semi-permeable. So, confined aquifer. So, yung well natin, of course, kinukuha natin yan or kinicreate no, through the aquifers. Ayan. Another saturated formation is, of course, the aquitard. It is a formation through which only seepage is possible. And thus yield is insignificant compared to an aquifer. Sandy clay unit is an example of an aquitard. So, ibig sabihin, for example, dito, no, itong clay na to, that is an aquitard. No? An aquitard, meron siyang lamang tubig pero through seepage only. Unlike sa aquifer na talagang sufficient yung amount ng water na nandyan. Aquiclude naman is a geological formation which is essentially impermeable. For example, is your clay is an example of an aquiclude. So, sandy clay, meron siyang portion no, na pwede pang mag-seepage. Kapag clay, essentially permeable, very slow yung seepage. And then aquifuge, on the other hand, is neither porous nor permeable. These are the rocks. No, in this example, our bedrocks, talagang impermeable na siya. Wala na talagang water dyan. So if you're going to think of this as a spectrum, no? So we have here spectrum of saturated formation from the most abundant water storage to the less facilitating, no, ng water flow. So I hope you understood the difference between those different formations. Yeah, and then these are the different kinds of formations. No? So now let's talk about groundwater flow. So yung aquifers, basically those are storage. Pag sinabi mong flow, so of course from point A to point B. No? So some of the water flows on the surface, forming streams and rivers. So the remaining water through infiltration penetrates the soil traveling underground, hydrating the vadose zone soil, recharging aquifers, with the excess flowing in subsurface runoff. So ito na yung tinatawag nating base flow. So of course, groundwater is very important. No? Ginagamit natin yan for irrigation, pwede din for drinking water if hindi siya contaminated. And of course, it sustains numerous ecosystems, especially no na nagko-contribute siya sa base flow ng mga streams. And then meron tayo ditong terminologies such as recharge. Recharge ibig sabihin no, nagdadagdag tayo ng water doon sa aquifer. So merong artificial, meron ding natural. So yung natural recharge, that is through percolation ng tubig, through precipitation. And then meron din tayong artificial, that is merong usually impoundment, no, na medyo malaki yung filtration capacity, and then doon binubuhos lahat ng mga floodwaters. Yan yung sinasabi ko. Okay, so usually yung direct method ng recharge is through flooding, percolation tank, ditch, subsurface, through yung mga wells, no? Pwede din, no? Na yung ulan is i-recharge through the wells. Okay, so ito yung mga different direct method ng recharge. So these methods are suitable kapag merong basin available and aquifers are unconfined. Pag sinabi mong unconfined, so merong permeability, no, sa upper layer sa ibabaw ng aquifer. So pwede tayo flooding, pwede din ito percolation tank, and then pwede din using yung ditch irrigation. So dito sa ditch irrigation, bale yung tubig no pinaka-flow dito along these canals, and then meron lang tayong tubo no that absorbs water from this point towards the farm, and ito na yung mga ditches no na yan na yung nagsusupply ng tubig. And then another type of recharge is yung subsurface. So first is injection well. So it is used to place fluid underground into the porous geologic formation. So ganito yung setup, no? Merong pipe from the source of the recharge water, and then merong recharge well, and then nilalagay or nilalagyan ng tubig, no? Yung pipe, and then papunta doon sa layer that is medyo porous. And then we have pitch and shafts. Then meron din dug well. Meron tayong tinatawag na induced recharge. So pumping naman yan. And then ito, very important, the different aquifer properties and characteristics. So there are different classifications of aquifers. So as I've said, meron tayong confined, bale, confined, no, from the word itself, it is bounded by two layers. So pwede siyang impermeable, pwede ding semi-impervious. Pag sinabi mong unconfined aquifer, merong free surface sa upper boundaries. Ibig sabihin, uh, above it is merong surface ng tubig. No? And then meron ding confining layer sa baba, pwedeng clay, pwede din namang sandy clay. Leaky aquifers, kapag yung aquifer natin is adjacent siya to semi-permeable layers, such as sandy clay. Perched aquifer naman, these are uh, aquifers, no, that is above the water table. Diba? Meron tayong water table. And then, pag merong aquifer above the water table, we call it perched. So, what are the different aquifer properties? So, first, meron tayong tinatawag na porosity. It refers to the presence of empty space or voids within the soil. No? So, porosity, that is simply the volume of voids over the volume of the porous material, VO. And then specific yield, it refers to the proportion of water that can be extracted from an aquifer when it is pumped or drained. So the formula is VD over V. VD is the volume of water drained by gravity. V is the total volume of the porous material. So we have an example. A hydrologist is investigating a sandstone aquifer and wants to determine its porosity and its specific yield. So the hydrologist collects data and measures the following parameters. So VV is 2,000 cubic meters, total volume is 5,000, and we're given the volume of water that can be drained under the influence of gravity is 1,200 cubic meters. So question is, what is the porosity? So porosity is simply VV over VO. So given naman yung volume of voids, that is 2,000, and then the total volume of the aquifer is 5,000. So porosity is simply 2,000 divided by 5,000. So how much is that? 2,000 over 5,000. Okay, so that would be 0.4. So yung porosity ng aquifer natin is 0.4. How about the specific yield of the aquifer? So SY, ang formula niya is volume displaced or drained by gravity over the total volume. So that is 1,200, no, that's VD over VO, 5,000. So 1,200 divided by 5,000, how much is that? 0.24. Okay, so that would be the specific yield. Ano ba yung unit ng SY? So parehong cubic meters, di ba? So that would be unitless. So any question about porosity and specific yield? Okay, so let's proceed. Next, let's talk about specific retention. So this is a property of our aquifers. It refers to the amount of water that is retained or held within the pore spaces of a soil or rock formation after it has been saturated, or it is the water that is retained against the force of gravity. So regardless, no, after the water has been uh, drained down by gravity, so yung natitirang tubig doon sa pore spaces ng soil, tawag natin dyan specific retention. So that is simply volume of the retained water divided by the total volume of the porous material or soil. V over V. Now, porosity is simply the presence of the empty space or voids within the material. That is simply the sum of the specific yield and the specific retention. So, for instance, a hydrologist is studying a clayey soil to determine its porosity and specific retention. So, the hydrologist collects data and measures the following parameters. We're given the specific yield, which is 0.2. Volume of retained water, VR, is 500 cubic meters. And we're also given the total volume of the soil profile, which is 2,000 cubic meters. So we're asked to calculate the porosity of the soil profile. So again, porosity is sum lang siya ng SY at SR. Given na yung SY, you just need to compute for the specific retention, which is VR over V. So VR natin is 500, V is 1,000. So that would be 0.2 plus 500 over 2,000. So what would be the answer? So 0.2 plus 500 over 2,000. So answer is 0.45. So that is now the porosity of the soil profile. Next, determine the specific retention of the soil profile. SR. So you know, 500 over 2,000. So that would be 0.25. So tama si Roger. So any question about specific retention and porosity? Okay, and then we also have the application of Darcy's law sa groundwater. So it is a fundamental principle in hydrology that explains how fluids move through the porous media. So alam natin yan, yung Darcy sa hydraulics, so that's V is equal to A times I. So K there is the coefficient of permeability, I is the hydraulic gradient. So yung V can be calculated using discharge over the cross-sectional area. Yung I natin, that is simply the change in hydraulic head over the distance that was traveled. So to find for Q, no, so meron tayong formula na Kia. So K there is coefficient of permeability, I is the hydraulic gradient, and then A is the area. So yan yung pinaka-formula ng Darcy. No? Q is equal to Kia. So hydrologist in this example is investigating the flow of water given yung K, which is 0.2, area is 1, hydraulic head difference is 5, the slope is 10. So calculate the discharge velocity using the Darcy equation. Okay, so we just need K and I, diba, for velocity. So that is simply K na, given naman yan na 0.2 Yung ating I, that is dH over ds. Di ba? Okay. So, how do we compute for for I? So, binigyan na, no? Head difference is 5. Divide natin sa length ng porous material. So, what is the length of the porous material? So, binigay lang sa atin is slope of the flow path. That is 10. So, pag sinabi mong slope, so paano mo kukunin ngayon yung length ng path given yung slope? So, slope is equal to rise over run. So, meron tayong rise na 5 and then run, slope na 10. So, 10 is equal to 5 over run. So, bale 5 times 10 is equal to 5 over x. So, 5 over 10. Diba? S. Wala kasi itong, hindi ko siya masulatan. Anyway, so 10 is equal to 5 over x. So 5 over 10, that is 0.2. 0.2 meters. So, big sabihin, V is equal to 0.2 times 0.2. That is 0.4. So, 0.4 meter per second yung velocity. Next is hydraulic gradient. So, yung I natin is, yun nga, no? 0.5, I is delta H over delta S. So, that is 5 over 0.2. So, 5 over 0.2 is what? 10. And then, discharge, yun na yun, Kia. So, 0.2 times 5 over 0.2 times area, 1. So, ilan yun? So, 0.2 times H natin is 5 divided by 0.2. Area is 1. So, the answer is 5 cubic meter per second. And then, we have here Bach for velocity. It refers to the average velocity at which groundwater flows through the interconnected void spaces or pores within an aquifer. So that is simply volumetric flow rate of water, that is V over N. So given here The volume flow daw is 10 cubic meters, porosity is N. So divide mo lang, no? So 10 divided by 0.4, what is that? What is the book for velocity? What is 10 divided by 0.4? Okay, so that would be 25 meters per second, no? Yung ating uh, Bach for velocity. Next, we have here the coefficient of permeability, that is K. No? So yung pinaka-formula niya is C d squared gamma over mu. So unit weight. So itong C that is dependent no, sa shape factor. Yung D naman, particle size ng porous material, bali average size. Unit weight is yung alam natin na value ng unit weight, and then yung ating dynamic viscosity na mu. So, yung value ng K varies depende doon sa granular material. So, just refer to this value ng K. Depende no sa material. Now, let's talk about mga wells. No? So, we have pumping tests. These are field experiment where a well is pumped at a controlled rate and the water level response, the so-called drawdown, is measured in one or more nearby observation wells, as well as optionally in the pumped well itself. So, pumping tests, these are done para malaman natin no, yung yield ng ating isang well. So, meron din siyang mga adjacent wells na tinitingnan para malaman no, kung ano yung behavior ng mismong aquifer. So, meron tayong tinatawag na constant rate, step drawdown, tsaka recovery tests. And then we use different water level measurements. Pwedeng manual methods, gamit yung ruler, or pwedeng data loggers. So, data loggers, nilalagay lang yan sa tubig. And then, after pumping, it automatically registers no, yung depth. So, yung pinapump na water, no, dinidispose yan sa malapit lang din na body of water. So, what is well hydraulics? It is used to understand the processes affecting when wells are pumped from an aquifer. Okay, so what is the drawdown pattern? So, usually, no, kapag nagpa-pump tayo, ang nangyayari is binabawasan natin yung tubig no, sa water table. So, nagkakaroon ng cone of depression. Ito yung cone. And then, ang nangyayari sa tubig is bumababa. No? Tinatawag natin yung drawdown. So, originally, ito yung water table. Bumaba yung water level ng SW. Tinatawag natin yung drawdown. So, itong height ng tubig from the bottom or from the reference, that is, we call that HW or the hydraulic head. And then, yung initial hydraulic head is itong H. And then, HR, yan yung hydraulic head no, at a certain distance R. So, for unconfined flow, ito yung formula natin, pi k H squared H, that is, ito yun, no, itong malaking H. And then, yung HW naman is ito. After the drawdown. LN, RW. So, kapag binigay sa problem is unconfined, so automatic, ito lang. Then, you just need the value of K, capital H, HW, R, and RW. Okay, so overtime lang tayo ng konti. Anyway, yes, para siyang soil mechanics, correct. So, meron tayo dito tayong tube well. Ayan, so meron tayong diameter na 0.46. So, of course, radius is 0.23. Ayan. The unconfined aquifer is merong lalim na 18 meters. So, 18 meters, that is from the initial water level papuntang bedrock. So, after drawdown, the depth of water is now 12 meters. So, ito yung initial, ito yung final. Given yung permeability, that's K, 24.5. Radius of the circle of influence is 275. Yan yung big R. So, ito yun, no? From here up until the outer circumference of the cone of depression, we're asked to calculate the discharge of the tube well. So, yung formula natin is, pareho lang to sa present ko kanina. Ang ginamit ng kanina is LN. Ito is common logarithm. So, pi k h1 squared minus h2 squared over 2.303 log 10, capital R over R. So, yung K natin is of course yung permeability na given, 24.5. Capital R is the external radius of the cone of depression, that's 275. Ang maliit naman na R is that is the radius of the well, 0.23 meters. H1, that is the initial height of the water table. H2 is the final height of the water table. So, direct substitution lang naman. Ayan. So, direct substitution. So, we'll get the value of 2,000 cubic meters per day. Okay. So, make sure lang natin no, na yung units natin are consistent. So, dapat radius and the values of H or in meters. K must be in terms of meter as well. No? So, direct substitution lang. K is 24.5, H1 is 18, H2 is 12, capital R is 275, small r is 0.23. So, ginawa dito is inaisa-isa niya lang. So, 18 squared minus 12 squared is 180. 275 divided by 0.23 is 1,200. And then, voila, no? Meron na tayong value ng Q. So, ito yung discharge doon sa tube well, no? Q. 2,000 cubic meters per day, or in terms of liters per second, 23.15. Okay? And then, another test na ginagawa natin is using recuperation test. So, sabi dyan, the recuperation test in an open well, the water level was depressed by 3 meters. So, meron tayo dito ng drawing, no? Ito yung tube. And then, ito yung initial water level natin. And then, after the pumping was stopped, when the pumping was stopped, no, bumaba yung water level, naging 3 meters. Ito yun, no? Ito yung naging after the pumping, ito yung kulay green. So, the recuperation was observed to be 1.2 meters per meter in 2 hours. So, after 2 hours, bumalik yung water level pataas, no? Ito yun, no? Naging 1.2 meters. So, bale, ito na yung pinaka-final na water level. Ito kulay blue. So, tinatanong is specific yield and the yield of the well, given yung diameter ng well na 2.5 meters, and we're also given a drawdown that is 1.5 meters. So, initial drawdown natin is 3 meters, this one. Final drawdown, itong H2, no? That is kung ano daw yung binaba. So, 3, and then minus 1.2, that is H2, that is 1.8. The time that it took is 2 hours para tumaas, no? So, formula natin for specific yield is K over A, or we call that specific capacity. So, we just need time, T, the initial drawdown, and the final drawdown. So, 3 is our initial drawdown, 1.8 is our final drawdown. So, we now have the value of Ka, which is 0.255 cubic meter per hour per square meter. So, yan yung units natin for specific yield. And then, ang pangalawang tanong is the yield itself. No? Specific yield, that's K over A. Yield itself, you just need the specific yield multiplied to the area and the drawdown. So, 0.255 yung ating K over A kanina. Area lang to ng well. That is 5 over 4 times diameter 2.5 squared. Times yung drawdown na 1.5, you now have the value of yield, which is 5.213 times 10 raised to the power of negative 4 cubic meter per second. Okay, so if we are to ask to design an open well, given yung yield, and then depression head na 2.5, so lista mo muna ano yung given. So yield from the well, Q is 0.01 cubic meter per second. So convert mo lang kung 10 into cubic meter per second. Depression head natin given na 2.5. Specific yield for clay soil, yung previous na nakuha, that's 0.25. So substitute natin dito. Q equals K over A area times H. So Q natin is 0.01. K over A is 0.25. Area is simply 5 over 4 D squared. Drawdown is 2.5. Itong 0.01, convert lang to into seconds. So, kaya to multiply ng 3,600. Then, solving for D, we'll get a value of 8.56 na diameter for this specific condition. And that's it. No? Diyan nagtatapos ang hydrology. So, any question? Okay, so that's it. Replay nyo lang yung presentation, no? Anyway, mayroong recording, so screenshot nyo na lang yung bawat point para meron kayong notes. Hanggang dyan lang po ba topic para sa final? So yes po, hanggang dito lang yung topic natin sa final. So condense ko na siya kasi next week sa 28 midterm exam, and then December 5 is wala na tayong final assessment na quiz. So yung effort nyo is para na lang sa departmental. So yung final quiz natin is yung final defense natin sa December 5. Hindi po kami makapag-proceed sa analysis, hindi po ako makapag-download ng ArcMap, sir. Try and try lang. Maraming mga YouTube tutorials paano mag-download ng cracked version. Unfortunately, na-delete ko na yung crack. Pero nakuha ko lang yun sa internet eh. So, maghanap lang kayo ng maghanap. Anyway, 5 kayo. 8. So, tingnan nyo yung mga YouTube videos, YouTube tutorials na may mga binibigay silang crack. Yeah, na-experience ko din yan. So, try and try lang. I think merong mga ano din, try nyo ding i-search yung sa ArcGIS mismo na binibigay, yung mga ano nila links, download links. Sir, kumusta po quiz namin? Aha, ang hirap. Na-check ko na siya. I cannot recall the scores. So, Aliana, ano lang, try and try lang. Wala kasi akong may bigay na crack kasi na-delete ko na. Ang tagal ko nang download kasi yun. So, wala na tayong ano, defense ng proposal. Pa-consult na lang kayo, no? Final defense, December 5. 2 weeks from now. So, kung ano yung score nyo doon, yun na din yung final quiz natin. Sa midterm exam, ang lalabas is yung mga topics tungkol merong infiltration, merong runoff, merong yung evaporation, evapotranspiration. Next meeting, sir, school na ulit tayo. Yes, after the 5 p.m. conference namin, meron pang, hanggang 5 p.m. lang kasi pala yon. So, big sabihin hindi kayo sakop ng ano namin, excuse. Yes, so, bali midterm exam tayo next meeting. So, ano pa yung concerns natin? PPT? PPT sa runoff. Runoff, di ba? S2 kayo, no? S2. Yan, publish ko na yung sa runoff. Lecture ngayon? Yeah. S2. Yan, nakapublish na siya. Okay, check ko lang. Under siya ng Module 3, Lecture Material. Okay, check nyo na. Pa-check if na-review ba. So, hindi ko pala nasali dyan yung isa pang ano, file. Wait lang. Anyways, I will just publish it. Okay, so another concern. So again, next week na yung ating midterm exam. Okay? Sige, paki-open ng camera para sa attendance. Ayun. Kita ko na si Braga is about the rest. Yung iba, okay, la Victoria. Pictorial tayo mamaya. La Victoria. Okay. Estilias. How about the others? Si Jo Marie. Si Villian. Dito si Villian ah. Wala siya. Okay, yung apat lang. Okay, picture. Wala pa tayong GC. Okay, ready? 1, 2, 3, smile. Okay. Sige, so God bless sa ano nyo, studies. So study for your midterm exam this next week. So wala yung choices. Aralin nyo lang yung mga ano natin, reference books, Subramania, and other hydrology references. Okay, so bye-bye and see you next week. Ingat.